Okay, so here we are back in section 4.5, and what I want to do in this video is finish up by showing you how to use the inverses of matrices that we found in the first part of this section to actually solve a matrix equation. We've done matrix equations where we had a scalar multiplication, but now we're going to look at a multiplication where it's a matrix times a matrix. So we can't just use a simple reciprocal. We've got to use that inverse matrix, the whole matrix, not just for a single number. So to do that, what you got to understand is that the general form of this type of equation is like this. You have A as one matrix times the unknown matrix X equals the product matrix B. So normally when I solve a multiplication type equation, I'm going to divide by A. But by definition of division, I can also multiply by the reciprocal or multiply by the inverse. So we're going to use that to do our matrices since we're not actually going to use division itself. So to do that, I will actually take both sides of my equation times A inverse, which on the left is going to leave me with just the matrix X, the unknown matrix, because A inverse times A will give me the identity, and I know the identity will give me X. But that means on the right-hand side of my equation here, I'm going to end up needing to multiply A inverse times B. So that means to do this, I need to know what the inverse matrix is for A, and then I'll actually have to do the multiplication of A inverse times B. So I've got to find the inverse so that I can use the inverse to multiply and figure out what my missing matrix is. Okay, so let's do that with our problem here. Let's start by finding the inverse of our first matrix A. And to do that, we need to start with the determinant. So the determinant, I do my main diagonals. Negative 2 times 3 is negative 6, minus the opposite diagonal, which is negative 5 times 1, so negative 5. And I end up with a determinant of negative 1. So then I'm going to use that determinant to find my inverse matrix, A inverse. And that's going to be 1 over the determinant, 1 over negative 1, times, we'll switch the elements in the main diagonal, and then we'll give the other elements the opposite sign. Okay, so what this boils down to, since I have negative 1 or 1 over negative 1, is I'm just going to multiply everything in my matrix times negative 1. So that's going to make my inverse matrix as negative 3, negative 5, positive 1, positive 2. So now that I have that inverse matrix, the last step is to then solve for X by simply taking the inverse matrix that I just found. So we'll use negative 3, negative 5, 1, and 2. And we're going to multiply that times matrix B, which was negative 2, 2. So as in the previous sections, when we multiply matrix to matrix, we do row times column. So it's going to be negative 3 times negative 2 is 6, and negative 5 times 2 is negative 10. 6 and negative 10 are going to leave me with a negative 4. And then when I do the second row, 1 times negative 2 is negative 2, and 2 times 2 is 4, so negative 2 and 4 would give me positive 2. So I end up with the matrix X as negative 4, 2. And if you'd like to check your solution, you're just simply could multiply the matrix X that you just found times your original matrix A and make sure that it comes out to be negative 2, 2 as your final matrix.